Okay, so we're just going to go over one more full example of a two-prop z-test. This is the one that we're going to go over. So high levels of cholesterol in the blood are associated with higher risk of heart attacks. Will using a drug to lower cholesterol also reduce heart attacks? Do heart attacks follow? With low cholesterol, maybe less heart attacks. So they did a study that recruited middle-aged men with high cholesterol but no other health problems. Volunteers were assigned at random. So this one's not going to be random sample. This is called random assignment when it's an experiment. To one of two treatments. It's an experiment. 2,051 of the men took the drug to reduce their cholesterol. 2,030 men just took the placebo. During the next 5 years, 56 men from the drug group and 84 men from the placebo group had heart attacks. Right away, I'm like, maybe there are less men who got the heart attacks, and maybe there's something to this, who took the drug. Do the results give convincing evidence that the alpha is 0.01? So they did that because this is a life and death situation. They don't want to make a type 1 error. They think that's bad. So they're making it only a 1% chance of making a type 1 error. That's the alpha level is the chance of a type 1 error. So we want to see if it's effective or not. So first you want to think about the null. So the null would be there's no difference, right? We think that the same proportions, I would consider, by the way, if you're doing this one, you might consider using meaningful subscripts. I don't think they do this all the time, but both I mean by that. So I might say something like the null is maybe P sub D for drugs, like the group that took the drugs minus the proportion, the true proportion that took the placebo, should be equal to 0. The alternate would be that, I think in there it says that they want to see if it's better, if the drug is making a difference here. So we want the proportion of the drug to be smaller, which means you're subtracting a bigger number, which means it should be negative. So the difference, we think the difference should be negative. So probability of the drug minus probability of the placebo should be less than 0. So those are your first two steps there. The way they wrote it out, they said this, and they also defined the variables, right? So, they called it P of G for the name of the drug, and then P of placebo or PL for that one. And then alpha level is 0.01. So you're supposed to state all three of those things when you do that. Second part is plan. You want to state what the name of the test is. It's a 2-prop z-test. Check the conditions. We saw random assignment, so that checks the random condition, less than 10%. 2051 and 2030 are both less than 10% of all adult males with cholesterol problems. That's for sure. And then the last condition is the toughest one to check, right? So you've got to kind of get out and figure out your p-hat pooled or common value here. So this would be a fraction. The two numerators would be the 56 and 84 there, I believe. So 56 plus 84. The denominator would be the 2051 plus the 2030. And I think you get like 0.034 or something like that. Okay, and so then let's see what they did. So they checked the large counts condition next, right? So you have to use that condition. So you do, just make sure you have to do it 4 times. So you do n times p hat pooled. So it'd be 2051 times the 0.034. That has to equal something that's greater or equal to 10. And then 2051 times 1 minus 0.034. That has to be a number greater than or equal to 10. And then 2030, I think you're getting the hang of this, times 0.034. We're using the same value 4 times. And so when you do that and you check them, it looks like that. They're all greater than or equal to 10, which is great. Okay. Next condition is due. So you're going to plug in the numbers here. Make sure in the standard deviation you use the p-hat pooled value, the 0.034. You can see that in the numerator of the the numerator of the denominator of z-score there, the 0.034 times 1 minus 0.034, or 0.9657. So you had to use that. You plugged in all the numbers, and you got this negative 2.47. Okay, so that's interesting. Let's just type this in the calculator, see what we get when we do this one in the calculator. It's my favorite one to do in the calculator, just because it's so easy. So I think it was 56. Oops, go menu 676. So 56, 2051, and then 84, 2030. And I think this one was less than, so we're going to go less than here, right there. Say OK. So they said the p-value was negative 2.47, which seems correct here. The p-value was so to get that p-value by hand or with the calculator here, I guess you go menu 652, which is norm CDF, negative infinity to negative 2.47, and just leave the default for z values there. And you can see we got a value very, very similar to that one, which is nice. Okay, so and it also shows you that, did you notice it in the formula, it shows you the p-hat pooled value right there where my cursor is. So that's really handy that it shows you the p-hat pooled value. If you forget to use p-hat pooled, if you do the testing calculator, if you're paying attention, you notice, oh, I was supposed to pool the p-hats there. Last question is, do the results of the study give convincing evidence? Well, we had a p-value there of 0.0068. So because our p-value of 0.0068 is less than the alpha level of 0.01, we do have evidence, convincing evidence, that this drug is effective at preventing heart attacks. Interpret the p-value. So that's basically the idea of an interpreted p-value is going to be assuming the null is true. This is the value, the probability that you get a result as extreme as you did or even more extreme in a common difference there between two proportions. So this is how they said it. I'm sure it's going to, well, that's the first part of the answer there. They said assuming the null is true, that there is no difference in the effectiveness of two treatments, there's a 0.0068 probability of getting a difference in heart attack rate for the two groups, or less than that by chance involved in the random assignment. So by chance, there's a 0.0068. This is very unlikely. We seem to have evidence that this is not true. Okay, that is your lesson for today. It's just 8 minutes long. Thanks.